this lesson, we will consider the other algebraic method to solve a system of linear equations in two variables. Step one is basically saying get all variables, equal signs, and constants lined up between your two equations. With the standard form, variables will be on one side with the constant on the other. With step two, we are multiplying one or both equations by a non-zero constant so that the coefficients of x or y of the two equations are same number with opposite signs. This is so that when we move on to the next step and add the two equations together, a variable will drop out, allowing you to solve for one of the unknowns. Step 5 is telling us to complete the ordered pair solution, and step 6, check. Before we get started, I want to make sure we understand something that is very important to this method, and that is we never add two equations together unless a variable will drop out. Keep this in mind before you do that, step 3. Both equations are in standard form. Notice how x's and y's, the equal sign, and constants are all lined up. Also notice how I do not have to do step 1, since the y's already have the same coefficients with opposite signs. We are ready to add these two equations together. When we add them together, the y variables drop out, and we end up with half of our ordered pair solution. We now need to go on and find the y coordinate. It doesn't matter which equation you use to find the other variable. As you can see here, I've chosen the first equation. In the end, we complete our ordered pair, y equals -2. Just as with the substitution method, we know we have the solution if it checks into both equations, and here is our check. Here's our second example. This time we need to do some work before we can add the two equations together. Remember, do not add the equation together unless a variable will drop out. In considering which variable to eliminate, I ask myself what is the least common multiple of the x coefficients and then of the coefficients of y. The least common multiple of the x's is 15 and of the y's is 4. Since neither the coefficients of x are 15 and one of the y's is 4, there's going to be less work to get rid of the y's. To get rid of the y's, we need, again, same coefficient and opposite sign, so we multiply the top equation by 2. After this step, we are now ready to add the two equations together. We are on our way to finding the first half of our ordered pair solution, and we get x equals 2. Now we need to go on and find the y coordinate. And again, you can go back to either equation to find the other coordinate. I've chosen to go back to the first equation. Again, perform the check to make sure that you have the correct ordered pair solution. This system is in standard form. Consider the least common multiple of the coefficients of x and y. Least common multiple of the x's is 9, y's is 3. There's the same amount of work getting rid of either variable. In getting rid of the x's, we need to multiply the top equation by -3. Now we're ready to add the two equations together. And when we do, both variables drop out and a false statement results. What does this say about our solution? Recall the two special cases we saw in the previous section. If the variables drop out and a false statement results, the lines were parallel, and therefore there is no point of intersection, there's no solution. If a true statement results, the lines were the same, and therefore there will be an infinite number of solutions. Here's a summary of the 3 different cases. Thanks for listening. Hopefully this has been helpful.